Uh, we had a little trouble here this morning. Zoom was being finicky again. Not sure what's going on. Okay, uh, it's August 10th. I'm going to talk about this paper and this. Actually, I read this paper and I thought it was kind of interesting. What attracted my attention was that he's Armbart Sumyan and art. And I started reading this paper and I thought, this is kind of curious. This guy's making these side comments about capitalism and this and that. And so I did some more research and I found out this guy's kind of a Marxist. So he's given us a Marxist view of cosmology. And, but I was actually more, he talks about quasars and ARP's ideas and Armbart Sumyan. So that's really kind of what I'm more interested in, but he sort of has a different take on cosmology. So I thought we'd talk a little bit about that. I don't know that people are real excited about that, but it's a different view. And okay, I'm going to start off here with whoops. Okay, can you see the present, my little talk here?
No. Oh, there it is.
All right. So I'm going to give a little talk here as an introduction. I thought maybe this might be helpful to people. Some he indulges in Marxist terminology, and uh, that might be a little bit confusing if you didn't know that he was a Marxist. I didn't realize this at first, and I was reading along, and I thought this is kind of puzzling. What is this about? And so I'm going to give a little introduction here to maybe help you understand what he's talking about. Okay, and here I'm going to talk about a Marxist philosopher's criticisms of modern cosmology. So he's got some criticisms, as you might expect, and discuss why he prefers the ideas of Armbart Sumyan and ARP, I spelled ARP wrong, to the mainstream consensus opinions. Now, my interest is really what really caught my attention is Armbart Sumyan. There's not really a lot of people that even mention him. And he's a Armenian, I believe he's Armenian. And he's got a number of papers out there. I think I've mentioned him before, but his work is kind of obscure. But people mention it in passing, but there's really not much in terms of substance that um, you can really find out about his ideas. And of course, we should be familiar with Halton Arp and his ideas by now. I know we've talked about that. I've talked about Arp's ideas. So we'll now kind of this guy's idea. His name is Abdul Malek. I should have mentioned that. I'll get to his paper later. Um, he's sort of trying to argue that Arp's and Armbart Sumyan's ideas demonstrate the dialectical aspect of the cosmos. So he's applying his Marxist ideology to cosmology. Now, I don't know that I've ever seen anybody do that before. So for me, this is kind of a different sort of take on things. And so anyway, the big points are that the philosophical basis of Marxism is the dialectical method. And I'm not really sure what that means, to be honest with you. And maybe other people know more about what it means.
Uh, I
Huh?
can just tell you very briefly, Harry. It's opposing forces. That's from Hegel. He
Right.
has the thesis and the antithesis, and they're resolved with the synthesis. The only difference between Marx and Hegel is Marx was a materialist and Hegel was an idealist.
Right. Okay, I understood that much about it. The um, and what puzzled me, and I guess this is going to be my point, and that is I'm not really sure how that explains cosmology. So I'm kind of want to try to make this point as to how does this relate to cosmology? That's really kind of what I'm trying to get at. And of course, you mentioned Hegel, so I mentioned here that Hegel. I a number of years ago was interested in Hegel. I've got a number of books by Hegel. I find Hegel kind of obtuse and obscure. I'm not a philosophy student or a philosopher major, so I'll just leave it at that. And what we're going to find out here is that the approach is mainly philosophical. He doesn't really it's not mathematical. He criticizes mathematics in the paper. So he discounts the scientific method, and he is trying to advocate a dialectical view of the universe. Now, it's not really clear to me what a dialectical view of the universe is. So we'll talk about, when I talk about his paper, I read his paper, maybe we'll get a little more insight in that. And what he's really focusing on is the evolution of galaxies. That's his primary thing. His primary point is he's talking about the evolution of galaxies. Okay, so that's what he's going to call his main observational evidence that justifies his dialectical analysis of cosmology. And so saying the key points of dialectical materialism, that's Marxism basically. Nothing exists without its opposite residing within it at the same time. Robert mentioned that. And this is kind of an idea that goes back to the Greeks, so it's not really particularly new. Motion is a process due to the conflict of the ever-present opposites. Okay, by motion is meant change or evolution in time. That's how I interpret what he means. And motion is the mode of existence of matter. There can be no matter without motion and no motion without matter. And basically, these are things that he talks about in the paper. What he means by these things, of course, the dialectical process in nature. So what he's trying to do, he's trying to look at cosmology and say, okay, I'm a Marxist. I'm going to try to interpret the universe in terms of my dialectical view of the world, of dialectical materialism, I guess you could call it. So he's looking, and to me, the idea of this idea of motion and change is Aristotle. Okay, so Aristotle talks about motion and change, and that's what Aristotle's physics is supposed to be about, as I understand it. Then he gets into, and this is where it gets a little bit obscure from my point of view, is he says the negation of the negation is what produces motion and change through the phases of the thesis, the antithesis, and the thesis. And the synthesis, okay, that's Hegel. The thesis, antithesis, synthesis, that's Hegel philosophy. And I think Bob mentioned the process is the conflict of opposites, okay? And that's another idea that goes back to the Greeks. And the dialectical opposites annihilate or produce a new synthesis. All right, so in the dialectical process in the universe, new matter has come into being inside galaxies. So there's some process or dialectical process that creates new matter inside of galaxies. Now, this is where Armbart-Simon's idea comes in. And that this is the process by which the galaxies proliferate. And he in the paper, he refers to Armbart-Simon, ARP, and the breeding galaxies reproducing themselves. So they're breeding, which is a kind of an interesting referring to how, to me, that sounds like animals reproducing, breeding, and organisms are reproducing or breeding. Accumulation. So, and he said the accumulation of matter provides the seeds for future growth. So this is kind of the idea, ARP's idea about quasars or seeds for galaxies. And galactic nuclei are the sources of the seeds. Now that's Armbart Sumian. Armbart Sumian said that the nuclei is the source of matter that's in galaxies. So the matter that we see in galaxies, particularly spiral galaxies, are the best example of this, where it looks like the matter in the galaxies, the spiral arms, they just come right out of the nucleus. Okay, and in well-formed spirals, there are usually two of these spiral arms, and they come out of the nucleus on opposite sides, and then they wind around the galaxy. And so Armbart Sumian, kind of thinks that the what's happening, what creates the galaxy, is what's happening in the nucleus. Okay, here's some of my comments here. It's not clear how the dialectical materialism produces the galaxies. Okay, maybe if when we talk about, I'm going to read the paper here. It's not a very long paper. I hope I don't bore you with it. And it's not really clear how this process occurs in this paper. It's not real clear to me. But he's asserting that it's so. It's not really clear to me what the opposites are that he's talking about. In dialectical materialism, you have these opposites. Presumably, there's some kind of force or something. It's not real clear to me what that means. What are these opposite forces? What are they? I'm not really clear. I understand that. And then kind of what my main conclusion is it seems like his whole argument is an attempt to sort of impose Marxism on the universe rather than his stated goal, which is to attempt to, his opposite is instead of forming an idealistic philosophy, in other words, he contrasts what he calls the idealism of the Big Bang Theory, which he calls an idealistic, mathematically oriented philosophy. And then you have observing the universe as it actually is. And he praises Armbart Sumian and ARP for taking that approach to science. And that seems to be the main opposites that he's talking about. Okay. Does anybody have any questions about this at this point here while I'm going to no comments, no questions?
Well, initially, Harry, I wasn't quite clear how you inferred that it was Marxist, but you said you did a little research on the writer, because without having done that, it's certainly true that Marx used the system, the dialectic system, to substantiate his ideas of dialectical materialism. But the converse is not true, because many people have used this dialectic system, as Robert pointed out, Hegel himself was an idealist. So I thought he was merely using a dialectic system, system of looking at positive aspect and the opposite, and then getting a synthesis.
Right.
I didn't see anything Marxist in it.
Okay, let me point out that I got some red flags when I read. Here's the paper. I got some red flags where he talks about capitalism and the capitalist system, and I'm going like, what has this got to do? What is the horrible capitalist system? The capitalist monopoly, I think, is the word that he uses. And I read that and I thought, what is he talking about? And that was kind of a flag to me. And then I started. Then his papers are at the I forget the name of the thing now. It's not the he has some papers at GSJ, and I can't remember. It's anyway. Shit, I can't remember the name of it. But anyway, he's got a bunch of papers there, and I started reading some of the other ones, and it was pretty clear that he was, he would insert these anti-capitalist, verbiage and into the discussion, and we'll see that here when I go through this paper. This paper has a different title: Big Bang Created or an Eternal and Infinite Universe. Now, I couldn't find the original paper with the title Armbart-Simeon Art and the Breeding Galaxies. That was published at Aperion. And Aperion has apparently disappeared, and I couldn't find any of their original, I couldn't find the original paper. It used to be that they had they had files where the previous publications had been kept, but I couldn't find where it is. So I'm using this one, which is essentially just the same paper with a different title put on. Does that help you any, Ian?
Yes, I did go through the paper fairly quickly, Eric, and I missed the parts that you just talked about. So that does explain it, perhaps.
Well, I was kind of, he doesn't really hit the Marxism stuff that heavily. And I see here I've got a problem. I'm going to have to go to the so I forgot this was going to happen. I can't move the, all right.
What if you click on the scroll bar?
I just did that. It's not working. It's, all right. All right, I'm going to read I have a copy of it here. Okay, so.
By the way, I think it was ResearchGate is the body.
ResearchGate. Yes, that's it. ResearchGate. Yeah, I couldn't remember that name. Okay, so two exactly opposite views about the origin, the evolution, and the formation of galaxies in the universe are discussed. The first one, which is mainly based on mathematical idealism and is generally accepted, use galaxy formation as deterministic and an essentially unidirectional condensation of diffuse matter created through a single primordial explosion, a Big Bang, about 15 billion years ago. The second view, here's where we get the dialectical part. The second view, based on limited observational and empirical evidence, asserts a rather intrinsic origin of galaxies, where new galaxies are formed from material ejected and or dissipated from the core of existing galaxies. A dialectical perspective in support of the second view is presented. So that's where that's the dialectical perspective. Okay. One major characteristic of an invariable truth. Now I have to go back to, I think, to the original, and unfortunately here we go. That's not where I would see here. I don't see how, is it scrolling now?
No.
It's not scrolling?
No.
All right. I'll just read this and hopefully you can listen. Do anybody want to read the screen? So one major characteristic of an invariable truth, scientific truths included, is that it makes its appearance at a certain time in history, but nevertheless it lays claim to unconditional validity for the past, the present, and the future. So unconditional validity. Once it is extracted from the real world, it becomes an alienated subjective force and assumes an independent entity of its own as if coming from outside. It then sets itself to control its very creators. Religion, state, capital are a few examples. Another important aspect of such a truth is that it has its origin in a first cause, a mystery which has to be accepted as an article of faith. The rest follows from it in a deterministic way, obeying the laws of cause and effect. Any new fact or phenomenon must fit in the scheme of this truth. If it fails to do so, then secondary, tertiary, etc. mysteries have to be incorporated to make it fit in the larger scheme. Wow. The general theory of relativity is such an invariable truth. So he's criticizing the general theory of relativity. Matter and space-time is engaged in a sterile and eternal love embrace, and this describes the architecture and the geometry of the universe. That's according to the mainstream. Albert Einstein himself claimed that one can only prove or disprove this theory, but any further improvement of it is impossible. Well, I've shown that to be wrong. The world then follows from this truth, obeying the laws of causality, the Big Bang Theory, inflation, dark matter, energy, black holes, etc., are secondary, tertiary mysteries that need to be invoked to bring the new cosmic phenomenon in line with the primary truth. Wow. Okay. Then he says the Big Bang Theory claims to be an invariable truth on its own merit, especially after the rival steady state theory lost much of its appeal. Both of these theories were proclaimed as corollaries to the general theory of relativity. If the Big Bang Theory required of God to create the universe at one stroke and then either forgot about it or follow on an eternal cycle of Big Bang and Big Crunch, the rival theory obliged him, referring to God, to keep an inventory and keep on creating matter where and when necessary for all eternity. So he's really basically disposed of both of the Big Bang and the steady state theory. According to the Big Bang Theory, the universe came into being with a primordial explosion, nowhere and no when, and is destined to follow a predetermined course set out as a mathematical plan. Starting from the size of a proton and undergoing an initial unimaginable rate of inflation, the universe is continuously expanding ever since. All matter, energy, space, time, or anything else in the universe, including us, are shards of a 10 or 26 dimensional reality of Plato's eternal realm of perfect symmetry, exquisite beauty, and absolute order. This ethereal realm is not given to our senses. We can reach it only through the power of thought and by following the logical consistency of mathematics. We can possibly get a glimpse of the original reality by piecing together the shards that are strewn around us in this universe and putting them in their place in the puzzle. The task of physics and cosmology is to reveal the image of the original reality in the details of the cosmos. Dark matter, energy, black holes, etc., are many mysteries needed to explain the dynamics of the galaxies. After completing the theory of everything, which is not far off, we will know the mind of God and can live happily ever after. Why, this is really kind of sarcastic. All right.
Stephen Hawking. I think he said the same thing.
Except with Hawking was advocating for this point of view.
Yeah.
The textbooks and professional articles on astrophysics, astronomy, cosmology, etc., start their deliberation assuming Big Bang Theory is granted. Any meaningful or at least rewarding research studies, etc., in this area must be concerned in finding the glory of this truth in heaven and nature. At stake are generous research funds, lucrative positions, and most of all, instant fame and glory. Only positive results are worthy of publication or discourse, only positive results. The negative ones are of no importance or consequence at all. In the jungle of electronic noise and the specter or pictures, one must hunt for positive signs of this truth. Okay. I'm going to, this is kind of bombastic.
Is there a date on this paper?
2005.
2005.
Now, he's come out with, he's got more recent stuff, but it's kind of the same sort of thematic idea, if you will. Let us briefly recount the history of our invariable truth of the universe and official observational cosmology of the recent past. Okay. The invariable truth started in 1916 with an all-inclusive equation. But a solution of this equation showed that the universe should be unstable, expanding or contracting, which was contrary to the conventional perception. So a fudge factor was put into the equation to keep order and peace in the heavens. A proof of this now invariable truth was needed, and it came soon enough. An experiment in 1920 led by Arthur Eddington, a mystic of numerology, measured the bending of starlight by the gravitational power of the sun. The bending was exactly what was predicted by the theory, but soon that particular experimental proof was also found to be a fudge factor, which Stephen Hawking described as a case of knowing the result wanted to get, not an uncommon occurrence in science. A case of knowing the result they wanted to get, not an uncommon occurrence in science. Okay, that's kind of how the mainstream does things. Edwin Hubble's discovery in 1929 that the galaxies seemed to be flying away from each other at a rate proportional to their distance also discovered the greatest blunder of a lifetime. The fudge factor in the original equation was unnecessary after all. Now that we have got back our invariable truth in its original form, I think he's referring to the expanding universe and the Big Bang. An unlimited extrapolation of Hubble's finding must mean that everything in this universe was at one point in the past from which it started off with a bang, giving the result we see today. The discovery of the microwave background radiation in 1965 sealed the deal forever. It showed a perfect isotropic picture of the universe that it was supposed to be. But there were minor glitches and irritations from the bad flies, like Gerard Henry Van Auclairs, George Abel, Vera Rubin, and others. Observations revealed that the universe was not homogeneous at all as far as one could survey. More than 15% of the supposed universe with the most sensitive tools of astrophysics. So in other words, the universe isn't homogeneous according to observational facts. Instead, matter is seen to be clumped progressively into stars, galaxies, groups of galaxies, clusters of galaxies, clouds, supercluster complexes that can span hundreds of millions of light years, and so on, often linked together in filament-like strings that border vast region of empty space where there is almost nothing at all. Okay, now this is kind of become pretty well confirmed and well established now. Well, not to worry. We can now let quantum mechanics into the picture to create some minor fluctuation in the primordial atom. These fluctuations must survive the super bang explosion, separation of the various forces, separation of matter and radiation, the incredible superluminal inflation of the early universe, and so on to form the clumpy structure of the cosmos. And one must now look for this in an anisotropy of the cosmic microwave background, CMB, radiation that was already found to be isotropic. Okay, we got 10 minutes here. Sure enough, experimental evidence came handy in 1977 when George Smoot and co-workers detected the CMB anisotropy in an experiment conducted from a U-2 aircraft. The final proof came on April 23, 1992 in the COBE, Cosmic Microwave Background Explorer, satellite experiment, again under the direction of Smoot. Who else? A lot of drama, tension, expectation prevailed during the 2 years of data collection. There was a lot at stake. Instead of devising or doing their own experiments, scientists all around the world were all hushed up in breathless anxiety and expectation about what this new Messiah was going to pull out. Some of them were saying, you could say we're close to a crisis, but the truth is we're getting down to the point where we should see fluctuations. We are now positioned to see them. And boy, we'd better see them. Okay, as expected, the result came out positive. Sigh of relief. The invariable truth survived yet another big test. It was greeted with comments like the scientific discovery of the century, if not all time, the holy grail of cosmology, and so on. COBE must finally put an end to the torture of the gadflies or any doubt as to the absolute truth of the Big Bang. But of course, the COBE results had to be positive, like Eddington's experiment, amid all this hype, expectations, browbeating, etc. A negative result would have necessitated further experimentation until we got a positive one. In science, as in life, we eventually get what we are looking for because we already know that the thing exists. Nevertheless, this episode speaks a lot about a science and its invariable truth when you have to hold your breath on the outcome of a signal experiment. It is all the more remarkable that neither the invariable truth of the theory of relativity nor any aspect of astrophysics, cosmology related to Big Bang genesis so far merited for a Nobel Prize. Okay. But what happens? Okay, now he's going to shift gears here. He's pretty much roundly, with sarcasm, given his opinion about the establishment viewpoint. But what happens if we try to look at the cosmos, stars, galaxies, etc., in this universe as they actually are, free of any preconceived idea or without the lens of an invariable truth, and then form theories, intuition, etc., based on these observed facts? Victor Armbart Simeon tried to do exactly this in the 1950s. He insisted that observation must take precedence over speculation in the study of the cosmos. He had found stellar associations, groups of stars, groups of 10 to 1,000 stars within the Milky Way, apparently of a common origin, but they were moving too fast for their gravity to hold them together permanently and to stop their slow dispersion. Armbart Simeon saw similarities between the dispersion of stellar associations and other cosmic phenomena, such as the ejection of matter energy from dying stars, the gradual breakup of binary stars, and later extended it to include the more catastrophic ejections in radio galaxies, quasars, etc., in which he found the same dispersive process in action. Armbart Simeon suggested that material is dispersed ejected from the galactic nuclei, variously producing the intergalactic gas. The features such as the spiral arms and or giving birth to new galaxies or clusters of galaxies. Dispersion from compact, superdense sources at the galactic core for him therefore represented the fundamental dynamics of the universe. This is exactly the opposite of the view that galaxies condense from the diffuse gas, clouds of gas produced from some events in the past, as Big Bang and steady state theories propose. Armbart Simeon, of course, was humble enough not to theorize about the nature of the compact source or how such catastrophic ejection of matter energy could take place, simply noting that there was no known physical process that could cause such enormous events. He probably did not want to minimize the great significance of these observations and his intuition about them by invoking some fearful and cheap cosmological beasts or monsters like black holes, dark matter, energy, etc. Okay, let's see, we got 4 minutes. But Armbart Simon's work received little attention, or at best met with dismissing skepticism. The two camps of theorists were beating their war drums and were busy collecting only those evidences in the cosmos that would support their respective invariable truth about the creation of the universe. For both of these camps, the study of galaxies was of secondary interest, since it was generally assumed that galaxies were formed by the condensation and contraction of diffuse matter. With the discovery of the microwave background radiation, the drum beating of the Big Bang camp became so loud that it drowned out not only the steady state camp, but everything else, Armbart Siman included. In the midst of this deafening sound of the Big Bang, very few nonconformists like Hamilton Arp were trying to bring back observation at the center of astrophysics. Arp was carrying on with his tenuous attempts to study the so-called peculiar galaxies, active galactic nuclei, quasars, etc. During his long career in astrophysics, Arp, along with others, have collected spectacular images of the cosmos that show a dynamic process of violent ejection and dispersion of matter energy as an important aspect of the universe. They found evidence of systems of galaxies linked by jets of nebulosity, showing the track of ejection of objects from a parent source, where an ejectum may have totally different redshift from its parent. Even without going into the controversy of the intrinsic nature of redshift and variable mass theory, these images and studies themselves confirm the validity of the great insight of Armbart Siman, i.e., the dialectical evolution of the universe. Not only is there clustering of galaxies on the largest scale, which is now reluctantly accepted as a fact, in the small scale also, family-like groupings of a high concentration of dwarf irregular galaxies, a host of small dwarf elliptical galaxies, distant globular clusters, etc., that cluster around large spirals like Milky Way and Andromeda were studied in detail by the Estonian astronomer Jan Einasto. These groupings, known as the local groups, now seem to be a general pattern in the cosmos. The giant elliptical galaxies such as M87 possess a population of globular clusters extending at large distances in space. These observations suggest the intrinsic origin of the satellite galaxies and the globular clusters, i.e., ejection from parent galaxies as envisioned by Armbart Siman. Okay, we got less than a minute here. I don't want to get cut off while I'm reading. Has anybody got any questions or comments so far here? I'm about halfway through. Robert's smiling. He must have something to say.
Yeah, the pretty loose stuff is about my only comment. Right?
Well, yeah, it is. But the point is, there's really not much. There's really not much about what Armbart Siman has to say. I mean, you can read his papers, and he doesn't really say a whole lot. He said a lot more in what he said here than you're going to find by reading Armbart Siman's work. Okay, it's kind of a suggestion. It seems like it's kind of a suggestion, and then it's kind of like a suggestion that people basically just said, "Oh, no, that's not. We don't believe that." That's not really happening. Okay. And all right. So what is the point here that we're driving at? These observations suggest the intrinsic origin of the satellite galaxies and the globular clusters, i.e., ejection from parent galaxies as envisioned by Armbart Siman. Okay, so what is the mainstream? What they're envisioning that there's this Big Bang, and the Big Bang presumably has some quantum fluctuations in it. You know, we have this quantum state of matter, and then they have now basically essentially determined what the physics of the Big Bang is by looking at the fluctuations in the cosmic microwave background. And then from that, they extrapolate back, you know, all about how the Big Bang happened and what its essential physics of it is. Okay, but now we're finding out in the observations that there are galaxies that have formed 200 million years after the Big Bang. That's kind of, you know, kind of upsetting the mainstream people, because how could galaxies have formed 200 million years after the Big Bang? That's really basically being a hard one for them to swallow down. And apparently, this is the latest information that's come out. It was 400 million years after the Big Bang a few months ago. That was the latest evidence from the JWST telescope. So they're pushing galaxies, finding fully formed galaxies very close to the beginning of the Big Bang. How did these galaxies form? That's a problem for them. And presumably the idea that there's this tenuous gas, you know, there's a gas that's produced. Everything starts in this hydrogen helium gas, okay, that's produced by the Big Bang, and that presumably takes some time for all this gas to condense and form stars. And depending upon you know, their theories, they have alternative theories. Some theories say the galaxies form first, and then you know, the clumps of gas are form big clouds, and then they condense to form stars in the galaxies. And then there's the other alternative, which is that the gas condenses to form stars, and then stars clump together to form galaxies. Neither one of those theories really does seems to be working out. So they're having a big problem now with the recent evidence of the JWST. Okay, all these tedious and painful efforts of the nonconformists, he's referring to Armbrudt, Simeon, and Arp. Now, there's more than just Armbrudt, Simeon, and Arp there, but these are the names that really basically have gotten most of the publicity and the attention. When he calls them gadflies, but it seems that these nonconformists should rather be called fireflies instead, because they provide the only dim light in this dark cloud from the Big Bang that threatens to become more and more dark. I think he's essentially referring to the dark matter and dark energy. Observational astrophysics, which is like natural science in general, started off as a tool for free and open inquiry of the cosmos, and which made great strides at its onset, now finds itself progressively being appropriated by a monopoly economic power and an interest group that use it in support of their pet theories. Now, there's that Marxism, monopoly economic power. I'm not really sure what that has to do with cosmology. But he says, and an interest group that use it in support of their pet theories. The fierce conflict between the paradigms of dialectics and causality that raged in the field of terrestrial nature, and which was won decisively by the former with the discovery of the theory of evolution and quantum mechanics, is now shifted to the field of the cosmos. I'm not sure what he's saying there. But how things stand, if in our search of the cosmos we follow the dim light of these fireflies, rather than the intense dark beam of an invariable truth, guided by the insight of Armbrudt, Simeon and the views of dialectics. Okay, guided by the insight of Armbrudt, Simeon and the views of dialectics. So he's sort of claiming Armbrudt, Simeon as his guiding light, I think. According to dialectics, now here we get the lecture on dialectics. According to dialectics, nothing can exist without its opposite residing in its own element at the same time. the unity of the opposites. The impetus for any development, change, evolution, in one word, motion in a thing or a process, is due to the conflict of the ever-present opposites residing in the very elements of the thing or the process itself, and not because of an impulse from outside, as causality believes. For dialectics, motion is the mode of existence of matter. There can be no matter without motion and no motion without matter. This motion is mediated by blind chance and iron necessity that is inherent in chance. Quantum mechanics also has reached the same conclusion. He didn't put a comma in there. So the notion of the existence of a primordial entity of perfect 10 or 26 dimensional symmetry of absolute order, etc., that bursts forth into this universe through a single event, such as the Big Bang, is a myth created by our mind and our mathematics. Okay, so I think this is really the essence of his argument. He's saying, in effect, basically, that what we believe in science is basically just a creation of our mathematics and the myth making of science. And so must also be the notion of a creator who pushed the button to trigger the Big Bang explosion, since there was no mechanism within the primordial entity of absolute order to trigger itself or to come to itself in the first place. According to dialectics, there is no leap in nature precisely because nature is composed entirely of leaps. So instead of there being one creation event that could be traced back to, God, of course, he's a Marxist, so you can't really say anything about God, can he? So, so instead of having a Big Bang, we're going to have a lot of creation events. So there's multiple creation events, not just one creation event. That's, I think, really that's the key point, I think. In the case of terrestrial nature, we observe that matter, life, history, and thought evolved through a series of revolutionary changes, qualitative leaps. According to the dialectical law of the negation, or a triad of thesis, antithesis, synthesis, mediated by chance and necessity and brought forth through the conflict of the opposites, or the contradiction of heredity and adaptation in its very own units. Chance is blind only when it is not realized in a necessity. If a seed from a plant falls on a stone or by chance carried to the moon, it will not grow there because there is no necessity for it, no scope for its further development. So this chance is sterile and it's there. But when a chance brings the same seed into a fertile soil, it develops due to the exacerbation of the conflict of the opposites within the seed. It negates itself into a plant, which in turn negates itself, the negation of the negation, to give an increased quantity of the seed itself. All change, motion, development in this view proceeds through the nodal points or leaps governed by specific laws where dialectical opposites either mutually annihilate each other or are sublated into a new synthesis, and so on, the negation of the negation. And where changes in quantity leads to a qualitative change and vice versa. It is the task of natural science to discover these specific laws and not to impose laws on nature created in the brain of man. So he's trying to claim that we should base our science on observational facts and not have what he would call an invariable truth paradigm, such as general relativity, and everything has to fit in the general relativity in order to be true. And so that causes all observational astronomers, when they make an observation, they're going to fit their observation into the paradigm, the invariable truth paradigm. And so that gives us black holes and all kinds of other strange things. In the realm of the cosmos, too, the galaxies, the units in the cosmos, must develop dialectically due to the conflict of opposites residing in themselves and mediated by chance and necessity. But while in the case of terrestrial nature, a definitive proportion and amount of atoms were given from which everything else evolved within a relatively short time in the cosmic scale, new matter has to come into being for the proliferation of the galaxies and the universe itself. Okay, that's his claim. But how could new matter come forth, and how could such enormous amount of energy as manifested in the quasars, for example, be generated? The compact source of Armbart-Simeon and the white hole at the core of the galaxy suggested by Arp fall into the same trap of causality like the Big Bang. These must have come into being and scattered around in the cosmos through some causal relationship originating in a first cause, like the Big Bang. Very large-scale matter, antimatter, annihilation processes are the only possible known sources of energy that can trigger the catastrophic events like quasars, but none of the theories and hypotheses mentioned above, including the Big Bang, allow such a possibility. So what he's saying here is that matter, antimatter, annihilation is the source of the energy that is creating the galaxies. In other words, his thesis is matter, antimatter, annihilation is the source of energy that's driving the quasars that we see in the that's pushing matter out of the galaxies, out of the nuclei of galaxies into the spiral arms and spiral galaxies. It's causing the radio jets and all these high energy events. That's, I gather, is his hypothesis there, that it's antimatter annihilation. Okay, a dialectical view of the universe as proposed recently, he's referring to a paper that he wrote, can provide a plausible basis for an understanding of the evolution of the galaxies in particular and the phenomenology of the cosmos in general. According to this view, matter in the form of elementary particles comes into being and passes out of existence as a dialectical and quantum mechanical necessity in the universe, which is void and infinite in space and time. Persuasive evidence from quantum electrodynamics suggests that virtual particles inhabit empty space with an increasing concentration close to an atomic nucleus. Some of these virtual particles can become real and the rest mass pass back to virtual as chance events and necessities by tunneling effects, and or as pair production by quantum fluctuation in the vacuum, and so on, to give rise to both matter and antimatter. Out of the innumerable possibilities, the law of chance and necessity determines which particles eventually prevail. Chance accumulation of matter and or antimatter at certain points can then provide the seeds for further growth and development of galaxies following physical laws. Since the appearance-disappearance of matter is enhanced where mass concentration is high, the galactic centers form the most active sites where new matter accumulates, and these centers become the theater where other random and periodic cosmic events can manifest themselves, such as those that we see as the active galactic nuclei, AGMs, quasars, etc. This basic process can then form the fundamental dynamics through which the universe evolves. So he's kind of speculating on what's going on inside of the nuclei of galaxies that's causing this eruption process that Armbart-Simeon talks about. And everything in this universe, from the galaxies to man, are therefore temporary and dynamic structures governed by physical laws and by the interplay of chance and necessity. Chance accumulation of matter at certain points in the infinite space and their evolution can give rise to the island universe around us, because new antimatter that forms is annihilated by reaction with existing matter, giving cosmic rays. These gamma rays, giving gamma rays. These gamma rays, along with other sources of energy, degrade through their interaction with matter to give a quantum mechanically necessary zero-point energy, the observed cosmic microwave background radiation. So he's saying the cosmic microwave background radiation comes from these gamma ray annihilation. The chance accumulation of antimatter in variable quantities and its inevitable interaction with matter can explain the origin of gamma and X-rays in the galaxies. The gamma ray bursts, active galactic nuclei, quasars, and other catastrophic events in the cosmos, for which no other source for the outpouring of such enormous amount of matter energy is known. Also, such large-scale catastrophic reaction of matter and antimatter can provide the energy necessary to eject the globular clusters, or large chunks of matter from the mother galaxy that later either grow on their own and or accumulate by gravitational attraction to form satellite galaxies. The Seyfert galaxy NGC 7603 and its smaller companion provide a dramatic example of such a possibility. The minor axis of the flat spiral galaxies provides the most convenient route along which matter energy can be ejected out in opposite directions. More limited scale of these random and catastrophic events may lead to the less dramatic effects, such as the deformation or limited fission elongation of symmetrical galaxies to form barred structures. So he's got a theory there for how barred spiral galaxies. That's kind of hard to really make sense of. Here's a picture of NGC 7603. It's kind of a peculiar galaxy, and as I recall, it's a Seyfert galaxy, so it's kind of attracts attention. The morphology of the various galaxies, such as spirals, ellipticals, irregulars, etc., must be looked at as the various stages following one another, and not existing alongside of each other, since their simultaneous creation, as official cosmology proposes. In the process of their evolution, dissolution, or their transformation into each other determined at any particular time by the net result of the random processes of appearance, disappearance, or matter, antimatter, production, annihilation, the collision interaction of the galaxies with each other, ejections from the core, etc., which are governed by chance and necessity and physical laws. That's kind of seems like a lot of hocus pocus. I'm not sure what he's talking about there. As suggested by ARP, it is possible that linear ejections of pairs of objects along the minor axis of the parent galaxy give rise to the companion galaxies, quasars, etc., while ejections along the major axis are stopped close to the ejecting parent, which then may form the spiral arms as Arm-Barth-Simeon envisioned. Evidence for such a transformation had already been found in 1961 when the French astronomer G. Cortés discovered that proto-spiral arms seem to have been ejected from the center of the Seyfert galaxy NGC 4258. A more recent NASA image of this galaxy is shown below. Well, I was wrong there. That was wrong. That's a different galaxy. Okay, moving on. It is entirely possible to speculate that some of the ellipticals transformed into spirals by forming proto-arms through ejection from the core, because unlike the case with the spirals, ejection along any direction will be slowed down by the existing bulk of matter. The spirals then slowly convert back to the SO or E-type galaxies through gravitational relaxation. The different types of galaxies are dynamic structures in which the various stages of formation, dissolution, succession, interconversion to each other, and not structures perfect in themselves since their formation after the Big Bang. Okay, so he's saying that galaxies can change from one type of galaxy to another through this ejection idea. It is, however, obvious that the shapes of some of the galaxies were determined by the random collision and or close encounter with another galaxy. So he's sort of giving a nod to the mainstream view. The morphology of the galaxies is therefore mediated by the dialectical process of dispersion, ejection, deformation. initiated by the catastrophic events of matter, antimatter, annihilation, and the regularizing effects of gravitational attraction. Time is an intrinsic and a relative characteristic parameter for a particular particle or a unit of assembly. It begins when the unit comes into being and ends with its passing away out of existence or with the dissolution of the unit. This view is the exact opposite of the notion of the creation of space-time and all matter energy in the finite past. If stars, galaxies, like humans, are temporary entities, so he's saying that stars and galaxies have definitive lifetimes, coming into being and passing out of existence. Coming into being and passing out of existence, that's important to this dialectical idea. As dialectics asserts, then we cannot measure the age of the universe at any particular moment by measuring the lifetime of the longest living star or galaxy, any more than an extraterrestrial can determine the age of the Earth by measuring the lifetime of, say, the longest living human being on Earth. He will get a ridiculous value of 100 years. So far, astrophysics has helped us to have a general understanding of the elevation of the higher atomic number chemical elements in the cosmos as a dialectical process. Only a similar understanding of the nature of the large-scale distribution of the galaxies, their origin, morphology, evolution, dissolution, etc., the energetics and the dynamics of the cosmos, the evolution of hydrogen and other very low mass unit particles that are not created by the fusion reaction in the stars and so on, guided by a consciousness of the laws of dialectical thought, will link us up with our understanding of terrestrial nature. Wow. A cosmology built on the fantastic notions of a first cause, mathematics, and a creator, a cosmology perplexed to explain how there can be galaxies, even at 17 billion light years away, far beyond the limit of the universe it predicts, or how the ratio of heavy elements like iron in intergalactic space and in the quasars, which are supposed to contain only primordial hydrogen and helium, can be as high as that in the galaxies, etc. A cosmology that gives spurious explanation for the formation and structure of the galaxies, or invokes mysterious monsters like dark mass energy, black holes, etc., to explain the energetics dynamics of the cosmos. And above all, a cosmology that titters to the brink with nervousness on the outcome of a single experiment will finally be done away with. Yay, let's hope so. Armbart Simon's revolutionary insight marks a point of departure, a nodal point, for further progress in cosmology. Now, this is the point I think that this is what I like. I think this is important. So I'm going to repeat it. Armbart Simon's revolutionary insight marks a point of departure for further progress in cosmology. It is a dialectical opposite of the paradigm of causality and of the single act of creation of all things that natural science fostered so long, a paradigm that has decidedly been proven wrong in the case of terrestrial nature, a paradigm that has progressively been built on professional careerism, conformity to the tradition in the sense that going against the trend is equivalent to cutting at the very branch of the tree you are sitting on. Only practicing visionary astrophysicists like Armbart Simon and a Darwin of the cosmos can rescue us and can help us out of the black hole that official cosmology has led us into. The rest of us can only hope and wait in anticipation. That's the end of it. And we have dead silence. So, Vladimir, what do you have to say?
A very good question. Thank you so much. I read his paper you referred to. I didn't understand anything. I never heard about Ambartsumian, never heard about him, references on his papers, his dialectics, and all this stuff. What I agree with him, there is a contradiction with mathematics and physics. Who is the first? And unfortunately, he was absolutely right when he wrote that right now contemporary cosmology is how to adjust experimental results to existing Big Bang model. It's absolutely wrong. And I agree with him, not only with him, but with all the guys, observational guys, who is looking for something in our cosmos. And only then they're trying to understand, to explain what they can see. This is the main point, what I understood. The second point is Marxism. I am originally from Russia, from Moscow. I left in Russia 34, oh, it was not Russia, USSR, 34 years. Marxism was always in the universities and all this stuff. And nobody liked it, like physicists, like myself. That's why, because there are common words about something, and there is nothing real behind these words. You read this paper right now, all of it. Do you know what is the mechanism of this creation? Marxism, you told Marxism, there is no God. But how to create new matter inside of these galaxies without God? I don't know. It's contradiction immediately. That's why, and Marxism, idealism in cosmology, I don't understand these notions even. Why we need to apply them? That's it. And what is important? Creation of matter. Dirac, he proposed in 1937 without any Marxism, idealism, and all this stuff from physical point of view. He proposed something, that the gravitational constant is dependent on time, it's time variable, and so on and so on. Where this dialectic? What is important, it seems to me that Ambarzuman, he stressed his point that there are two in cosmology. One of them, you started from Big Bang and everything already done. You cannot do anything. It was only one moment. It was some creation test process, and all the rest will follow this first point. And they're trying to find uh, all the causes of our changes right now in the very first moment at T0, and that's it. All is written there. God, He created not God, I'm so sorry, Marxism, no God. Yeah, it was created from the very beginning, and then everything definite. You cannot do anything about it. It's changed. And he and Arp I know very well. He was a very great astronomer, great ideas. That's why I don't know, I don't understand this even mixture. This paper belongs to Ambartsumian and Arp. What is the real Arp in this paper? I don't know. That's why
Well,
for me, it's a philosophy. It's not physics. It's a philosophy because dialectics, Marxism, it's dialectic. It's not physics for me. And all these notions, all this game of words, I don't like too much because I'm a real guy. I do like something. You told something. Please tell me what you mean. What does it mean, this physical mechanism? What does it mean, this and that, and so on and so on? That's why all these common words and mixture of them, it's confusing so much that you missed even the main point. What do you want to tell us? Tell us in a short way, in a couple sentences, what is your idea? What is your point about the cosmology and all this stuff? Unfortunately, it didn't help not only to me, but I suppose to all our group to understand what they're talking about. What is this paper about? How it helps us to understand the results of GWST and all this stuff. As for the galaxies, you told about the mechanism how to create galaxies. But unfortunately, you missed very important point. To have a galaxy, you must create the first stars, then to explore them, to generate some heavy elements, then to create unbelievable black hole. With galaxies, there is no galaxies without black holes. You must go with this new step, black holes, and only after that, maybe together with it, you can create all the galaxies what we can see right now. It is so long story that there is no way to get it. That's why, thank you so much for this finding for me. I never heard about it. I'm so happy that there was something. By the way, 2005, There was no already USSR, there was a Russia, there was no even Communist Party at that time. I don't understand why Ambartsumian followed this Marxist ideology. That's why I don't understand it. I don't understand what enforced him, because when it was USSR, you must follow your dialectic, Marxism, and so on and so. It was must. But in 2005, there is no must. It's his own opinion. It's not Marx. It is him
All right,
proposing us.
let me comment here and interrupt a little bit. I think you may be misunderstood. I don't know that Armbart Sumian actually advocated anything about dialectical materialism. I think that's the author of this particular paper. So the author of this particular paper is taking, he's imposing dialectical materialism on to what Armbart Sumian and Arp are saying. And so I don't think they're saying that. And he's trying to argue for an alternative. As I see it, he perceives this paradigm, which he's the Armbart-Sumian art paradigm, let's call it that. He's contrasting that as a dialectic against the prevailing mainstream Big Bang theory. So what he's essentially proposing that the Armbart-Sumian idea of how galaxies are created, he's making that as an antithesis against the thesis of the Big Bang theory. That's how the dialectical materialism part, I think, comes into this guy's idea.
Right, you're right. But unfortunately, how they create, I don't know. Do you know? Can you explain his idea how to create galaxies? I don't
Well,
know.
he's
It's
kind of
only
vague
words.
about
It's
it.
only words.
He's kind of vague about it. He's got some kind of antimatter idea, and it's kind of vague and very ambiguous. And I think in some of the later papers, he tries to talk about it in a little more specific detail. But it's kind of my point is that what is of interest to me is that this is one of the first papers where I've seen anybody really advocate for Armbart Sumian's point of view. I don't know. I've never seen anybody advocate for Armbart Sumian's point of view. It's like Armbart Sumian, just kind of like got dropped into a memory hole and disappeared. And
Antimatter, but we don't have antimatter. Nobody showed us where this antimatter is. To create your paradigm based on non-existent, notions, antimatter. I don't know where it is. Show me. That's why, he was against Big Bang, no problem. Yes, I agree with him. Everybody now against Big Bang model. But what he proposed himself, I don't know. I don't know. As a physicist, I don't know. Maybe as a philosopher, maybe it's good, but not as a physicist. I don't understand, because I do like, if you told something, give me the idea, mechanism, whatever, how it goes. There is no how it goes. It's only words about. Yes, against Big Bang model. Okay, there are some other guys. Some guy he told, Big Bang never happened, and that's it. Never happened. It's the end of the story, and you know this guy. Okay, that's why.
I think that's what he's trying to say. I think is, yeah, you can sort of the prevailing idea is we're going to have this Big Bang. That's the big mystery that they have. There's this Big Bang, and then after that, they've got this. They've developed this theory, okay, of based on particle physics. Gamow and his buddies Alper and and those guys. And so they have a physical theory that they can say, okay, this is physics. Okay, so they have a physics cause and effect scenario. But whether any of it's true is just, as far as I can see, is just, I don't believe any of it really, any of this physics of the Big Bang. And, you can get these books and they'll tell you all about all the reactions that occurred in the early universe, et cetera, et cetera, et cetera. yeah, that's physics, but is any of it true? I don't think so. And I think that's what this guy is really kind of getting at he's sort of saying from a philosophical point of view, this is nice. It's a nice story, but do I believe it? No, I don't. And why do I not believe it? Well, I've got this guy, Armbart Simeon and ARP, that basically tell me that the universe doesn't really look like what you're claiming it looks like. Okay, they're seeing things, making observations that don't agree with your theory. So maybe your theory is not wrong, not right. I think that's his point, kind of in a vague nutshell.
I agree with you. To criticize Big Bang model, it's okay. I agree with it. But what he proposed instead, this is my main point.
Well,
I agree
they don't,
with his conclusion about the Big Bang model. But what about your own model?
okay,
I'm asking.
here's the issue. The issue is something's going on in the nuclei of galaxies that they don't really understand. What the mainstream has done is they've said there are black holes there. Okay, and so they can say, the mainstream can say black holes, they're at the center of galaxies. That explains what's going on. No mystery, nothing to see. Okay. Now the problem is, of course, since they're already have decided that there's black holes there, then there's no real reason to develop a theory about what's happening in the centers of galaxies that's producing matter, because they got black holes that explain things. So they've got an explanation. They've got a physics that explains it. Black holes are sucking in the gas, and so then they're creating these energetic events. And so there's no, it's just, there's nothing really there to see. So nothing really of any significance. It's just a pedestrian process of black holes sucking in gas. That's all that's going on. And every once in a while, there's a big eruption and stuff gets exploded out. But nothing to see here. It's just pedestrian physics. And Armbart Simeon has a different view of it. He says there's some physical something that we don't know, that matter creation is occurring in the centers of galaxies, and that's where the stars come from, and they get pushed out from the nuclei. And of course, the main evidence in support of that view is the spiral arms of spiral galaxies. And then, of course, since then, of course, you have the radio galaxies, which obviously something's going on in the nuclei of these galaxies, because the radio pictures show these jets, highly energetic jets coming out of the nuclei. And so something's happening inside of these nuclei, inside of the centers of these galaxies. We don't know what it is, obviously. And all we can do, I guess, at the current situation in science is just speculate. He's speculating. He doesn't know.
But what about jets? Let me remind you that we have these jets in our galaxy. We don't need to go far away. We have Fermi bubbles as the results of the jets of our black hole inside of our Milky Way galaxy. This is the point. Many times I talked about these Fermi bubbles. They're generated by jets, and it's proved, experimentally proved. Astronomers gave some names, even some chimneys, something like this, all the matter going not inside, not sucking by black hole. On the contrary, it goes outside. And Big Bang model accepted.
Okay, well, we're back.
Just a question, if I may, just about the political situation, maybe, when Albert Simeon was developing some of his theoretical theory-based ideas. It seems that at that time he perhaps questioned general relativity and the concept of black holes. So I'm just wondering, 40 years ago or more, what the situation might have been in the Soviet Union in regard to questioning the orthodoxy of physics, because we keep on talking about what's been happening in the West, particularly say in the United States, where careers have been ruined. ARP would be one example of that. Um,
Yes.
so, I'm just wondering what
Um,
happened in the old days in the Soviet
I'm
Union.
not really sure how to answer that. He had I think this is in Armenia. I don't know that much about Armenia. And it was at the Armenian Observatory. And I'm not really sure. Um, I, you're asking a question is kind of like in the black hole. You know,
Vladimir
uh,
may know more about it though, because one of the reasons I ask it is I attended myself one of the conferences. One of the organizers was Pulkovo Observatory in St. Petersburg. Now
right.
it said in the little information I drew up that Albert Sirmium was involved in that observatory. It was Leningrad at the time, and so on. Now, the conference I attended was very open, and we were all questioning this. But this was after Soviet times; it was in Russia. So I'm
Right.
just wondering, 40 years before that, was it possible to have a free conversation about?
Well, if you look at his papers, I at one time had anticipated doing a talk on Armbart Simeon. And what I discovered was it really wasn't enough. There wasn't really much more material than what I talked about today. And it's kind of vague and obscure and not really, it's he did he I when you talk about this, there'd be he established that the stellar associations were moving apart. The stars weren't gravitationally bound, and he did a lot of work in that area, which I don't think was really controversial in any way. Okay. I think the controversial part was this idea that galaxy nuclei eject matter to form stars. And I think that's what the controversial part is. And regarding that, I don't think that he really said much more than just that statement. In other words, he doesn't really provide a mechanism or explain any physical, how it happens physically or anything. It's kind of there's really that paper that I read, that's really kind of a summary of really what he says. That's really why I wanted to discuss it today, because that's about as good a summary as I could find. It's kind of what people refer to his idea, but then when you try to find, he never really doesn't, I don't think he ever wrote a paper where he actually elaborated on the idea very, very thoroughly. So it's bits and pieces. It's not really, it's not like he wrote a monograph or anything that describes this in detail and lists all of his observational facts and gives all the supporting information. It doesn't look like there's any such thing that I could ever find.
So it's probably the writer of the current paper that we're talking about today. I just don't have his name at the moment. Who's introduced this sort of isms into the system, the political situation, which is always very dangerous to introduce any ism, whether it's Marxism or whether it's a religion, into your ideas of science. Very, very dangerous. But perhaps he's responsible for doing that rather more than Albert Simium.
He's taking the ideas of Arp and Armbart Simeon and claiming that they support his dialectical materialistic view of the world. And this guy's name is Abdul Malek, and he's, I guess, I don't really, ResearchGate. Yeah, I forgot the name of that. He's got some papers there. Apparently, a lot of them have to do with biology and biophysics. So I don't think he's physicist. I think he's maybe a biologist or something. It's not real clear to me. I didn't really look into it in a lot of detail. But he lives in Canada apparently. I guess he's still alive. He's got some recent papers with dates on to recently dated papers. So I guess he's still doing stuff. I had so that I think he's trying to impose his Marxist worldview on cosmology by the work of Armbart, Simeon, and Arp. And I'm not really sure that it really works because as Vladimir had pointed out, what's I don't know what the dialectical process is that's happening inside a galaxy that's causing the galaxy to, he's trying to invoke this idea of seeds and, by an analogy with nature. And that that needs more. Actually, Vorontsov Ilamenov is another Russian. He does a much better job of making that argument than this guy in his paper. Now, he's another Russian that's kind of obscure. And he had this idea of gemmation and that galaxies reproduce kind of like plants do. They have seeds. That's the seed idea. And that parts of the galaxies will break off. Okay. And so like a spiral arm of a galaxy will break off and then form another galaxy. Okay. And then galaxies might, different, he points out, shows these photographs and he points out these various processes where galaxies appear to be reproducing kind of like primitive organisms might reproduce. Fission, like for instance, two galaxies, where they show these pictures where the two galaxies are supposedly merging. Vorontsov Ilamenov would say, well, they're splitting and it's a fusion and the two galaxies are reproducing by a fusion, like similar to like how maybe I'm not using the right word. Fusion's not really the word. Mitosis, where they split. The cells divide, and so galaxies would split in half and divide, or parts of them would split off and form another galaxy.
Well, it's like a propagation.
Right. In other words, yeah. And so, but he didn't get a lot of attention. He didn't really make a big deal out of it, make a big theory out of it. He just, put together a catalog that showed all these photographs and he explained them by this biological reproductive thesis. And so the idea that, that galaxies reproduce similar to organisms is not really exclusively to Armbart, Simeon, or Arp. Arp uses the term seeds where he says quasars are seeds of galaxies. And in his paper, Abdul Malek is sort of saying, well, it's kind of like the seeds falling on the ground. And I didn't really understand that. It seemed kind of, I really don't understand the whole idea of how dialectical materialism applies to this process. It didn't really, it really doesn't, it's not really understandable to me. I just thought it was interesting from the point of view of that he talks about Armbart Simeon's ideas and Arp's ideas in an approving manner. And he kind of criticizes the mainstream along the way. So I thought that was kind of interesting, maybe worth talking about a little bit. But I don't know that that particular paper is pretty old. He has some recent papers, and I think they're trying to elaborate the theme. If you're interested, you might want to go to ResearchGate and take a look at them. Okay, I'm going to all right, here we go. Okay, is that on the screen?
No,
You see the picture there?
no.
Oh, I didn't
Yes.
share the screen. You see it?
The
Oh,
text
there you
element,
go.
there it is. Yeah.
I think I'm sharing the screen now, right?
Yeah, yeah.
Okay, this is an example of it's kind of interesting. The At the top you have in the center you have this galaxy. It's a radio galaxy, and it's very difficult to see here the green. Can you see the green?
Yeah.
You see where my pointer is pointing. Okay, so this is a classic radio galaxy that's got two lobes. Okay, you got a lobe at the top, okay, and a lobe at the bottom. And then above that, you have the thing that's marked I. You see I, that's a quasar, okay? And then down at the bottom, there's that looks like it's marked Q. That's another quasar. And you see the quasars are opposite, pretty much the same distance away from the galaxy that's in the center. And this is kind of an example of the sort of thing that ARP likes to point out. And of course, the mainstream says that these quasars aren't really associated. But what's interesting about this is that the radio galaxy part, the green part here on the upper part, above the galaxy, is kind of as the same shape as this quasar thing. You see this quasar thing looks kind of like a question mark or a fishhook. They're called horse heads, and that's kind of a strange thing. You see what I'm talking about here? Can you see that in the figure? And there's like this question mark shape. This quasar is in the center of it, and then there's this tail-like thing that kind of looks like a fishhook or a question mark. Can you see that?
Yes, we can.
Okay, now it turns out that the radio galaxy map makes the same shape. Okay, and it kind of looks to me like there's a scale difference between the radio map and the optical map, so that the radio map should be on top of the quasar. You follow what I'm saying? It's to me, this is a really kind of curious. It's a curious thing. Why do you have this quasar and it's got a tail? Usually quasars don't have tails. The one at the bottom doesn't have a tail, okay, but it doesn't have this dispersed, question mark. The point is that the green stuff kind of forms a question mark, and the quasar above it sort of makes a question mark. Okay, it's kind of an interesting, curious case. So, is the radio map wrong? Maybe it should be coinciding with the optical object above, and if that's the case, then that would sort of tend to indicate that the quasar has been ejected by the galaxy. Okay, that's
Oh no. Oh no. Oh no.
why not?
Okay, I don't want even to comment it. It's impossible. It's impossible, man. Some small piece will generate some bigger big piece. I don't know where the matter from, where it came
Well,
from.
that's what the argument is about. And they've been discussing it. Of course, the mainstream doesn't like this idea, kind of like you. Um, where did they, what's this, why are these two quasars here? They're just directly opposite and apparently coinciding with the radio emission that goes right back into the core of this galaxy.
Combination, believe me. Show me at least the second one, and you will not find it.
Well, that's the mainstream viewpoint. I
Do they
want to
have any
know whether
mechanism how
lots
to
of,
explain it?
well, they don't have an explanation, so it's as good as theirs, which is nothing really. They don't have an explanation as to what's going on.
Are the three objects, the two quasars above and below and the galaxy in the middle, approximately the same distance from Earth?
No, that's the argument, because when you measure well, first off, there's no way to know that. How would you know that?
Well, then we're just cherry picking data and fantasizing. I mean, this is really not even science.
Yeah, it is.
No, it's not.
Yeah, it is. Why is it not science? Tell me why it's not science.
Well, I mean, if we don't have
I
any,
mean, it's an observational fact. Okay, science is
Observational,
an
agreed,
yes.
observational
agreed, an
fact. It's an
observational
observational
fact,
fact.
agreed.
Huh?
But
Yes,
It's an
agree.
observational fact.
if we can't pin down that these three objects are the same, roughly the same distance, um, how can we then speculate about that the two quasars came from this particular galaxy? You see
Well,
what I'm saying?
because the radio map shows the radiation coming out of the galaxy and basically almost exactly superimposed on the one at the bottom is almost exactly at the same place where the quasar is. The one at the top is a little off. So
So you're saying, for clarification, that the green material is associated with the galaxy?
well, yeah, it's obvious. It goes right into the center of the galaxy. Can you see it?
Yeah. Oh, okay. Thank you for that clarification.
So you see, here's the jet at the top. The jet comes right out of the galaxy and goes right on up, but it doesn't quite get up to where the quasar is. But the shape of the radio map looks almost exactly the same as the shape of the optical of the quasar. So the question then becomes, in my mind, it's just it's just too much of a coincidence.
Yes.
So this is the superimposition of two images taken at different times. Is that what you're saying?
One is a radio map and the other is an optical photograph.
So yes, it is a super. Oh, okay.
Anyway, these are the sort of this is kind of what the argument's about. Well, that's just a quirk. It's just a chance thing. Yeah, you can argue about that forever and not really accomplish anything. Arp's kind of argued this point for a long time. He finds quasars, and calculates the probability of the quasars being associated with the galaxy by chance, and finds that they're extremely small probability, 1 in a billion chance and that sort of thing. And they say, oh, that's still a chance anyway. It's still just accidental. It's not real. And they've been arguing about that for years. But this is a kind of an interesting one.
Yes, it is interesting. You are right.
Okay. The other thing I thought was kind of interesting, and I wanted to point out, is that in one of the papers that this guy, Abdul Malek, which means servant of the king, which I didn't know that, but I discovered that when I was poking around. Abdul Malek is his name. That means servant of the king. And in one of his papers, he talks about where Einstein produced a paper in the 1930s where he denied the existence of black holes. And I'd never heard this. Have any of you ever heard of this?
No.
And I went to look it up, and it's one of those cases where it's paywalled. You can't really you have to pay to get a copy of the paper.
Yep.
Okay. But supposedly, and he quotes Einstein saying that black holes are impossible.
Yeah.
Einstein proves in his paper that, Go ahead.
I've heard of it. But they dismiss that he got it wrong.
Yeah, right.
Yeah.
Sure, Einstein got it wrong.
Yeah. So they say
I just thought that if Abdul Malek means servant of the king, Einstein means one stone.
Yeah, but
So you've heard of this, Roger?
yeah, so
Okay.
they say his theory predicts black holes, and so Einstein's right because his theory predicts black holes, but when he actually talked about it, he thought they weren't there. So he's right and he's wrong.
Well, I found that I hadn't heard of this before. I hadn't heard of this paper, and and I was kind of surprised when he mentioned it. He sort of, in some of his papers, he sort of wants to, find anything. He's like a dissident. He wants to find any contradictions in Einstein or in the mainstream that he can point to. That essentially throws. Basically, he's throwing rocks at the mainstream.
Let me give some comment about Einstein. Do you know that, first of all, in the Big Bang model, it was a vacuum, there is no ether. But in paper 1920, he told no Big Bang without ether. We must use it. There is no way to go away ether. And what is important, let me remind you, Friedman in 1922 developed already his model, his equations, based on ether. You see, there was no ether, then existed ether. Some contradiction inside of this model, even by the head of this model, genius Einstein. He
Well,
cut the ether, then he introduced ether in his model, in his theory.
well,
That's why, guys, he maybe about the black hole, it was the same story. He accepted them and then he rejected them. I don't know what is his real opinion was about his own model, about
Well,
his own
I wanted to
equations.
mention here, I talked a little bit about that in my presentation, where when you look at his paper, and I specifically mentioned this, that when he was, that there's this contradiction as to whether or not does the clock actually run slow, or does it only appear to run slow to a observer in the other frame of reference, and it's pretty clear that he says, when in one of the papers where he's answering questions, it's pretty clear that he says that as far as length contraction is concerned, the observer who's moving with the rod doesn't see any length contraction. Okay. And yet, and so then that's an obvious contradiction. And so what happens
Yes.
is that you can justify any argument you want to make by pointing to something that Einstein said, because he says all kinds of contradictory things. So you can get
Yes.
anything out of him to justify what you
Yes. It's
and
exactly my point. All this theory, internal contradictions it has, all of it. And even the father of this, theory, he has all the contradictions, all of them. There is no logic in his model, in his theory. That's why he jumped from one point to another one, because he didn't know how to put it together.
right. And so it's not clear to me. It's and so you get into this argument where you say, well, Einstein is wrong because of blah 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 blah, and then somebody can always come back and say, no, what he really said was this, and not that, because his stuff it's just full of contradictions. Anyway, I only brought up the black hole thing because I thought it was kind of interesting that he'd actually written a paper where he proved that black holes couldn't exist.
What his arguments, how he confirmed his conclusion, they don't exist. Based on what? On
Well, I
raw
didn't.
mathematics or on logic, on what?
Well, as I pointed out, I was going to read it and try to get a copy of it and take a look at it, but I was, it was black paywalled, and they wouldn't let me download a copy of it, and so that was this for it. I just brought that up as a footnote. It's just a footnote. Maybe it was worth looking into, at some point in the future, but it wasn't really relevant to this particular talk. The real point of my talk here today is to basically talk about Armbart Simeon and art, and I thought his philosophically based criticism of the mainstream was kind of interesting, and it might be enjoyable. Um, that's kind of the summary. I don't know. Did people enjoy kind of his rather pointed barbs aimed at the mainstream? He had a lot of pointed barbs aimed at the mainstream.
Well, it was written in a fairly facetious style, which was somewhat entertaining.
Yeah, I thought it was. It was not dry and boring, and
Yes, quite so.
Jan, can I ask you the question? When did you visit Russia? You've
Who,
talked
me?
about this conference many times.
Yeah. Well,
What
that was
year it was?
the science STG space-time gravitation conferences. There were a number of them. I visited in 2004. I went to the conference there in St. Petersburg. I gave a paper at it actually.
Okay,
But
okay, thank you so much. Because I left USSR in 1991. That's why you saw already new Russia, new
yeah.
atmosphere, and all this stuff.
Well, I've been there a number of times. I was first in the Soviet Union in 1976. I did a tour, an interest tour for 2 weeks all over the place. I was in Russia. I was in Armenia. I was in Georgia. I was in Azerbaijan. I was in Tbilisi, which is the birthplace of Malky. And also I believe of Joseph Stalin. So that was quite enlightening. Things that had changed a lot. Actually, I stayed in the Hotel Rossiya in Red Square, which was the largest hotel in the world. And when I was back there in more recently, not 2004, but more recently, it might have been about 2012. I was saying to some of the guides there, "Oh, I stayed over there. Where is it? It had been knocked down. Nothing there anymore. It was like a sort of a Stalinist building, very imposing, huge building, but it was knocked down. And the guides, one girl, she was an interpreter. I think she'd been born in 1967. She didn't remember the hotel, but I said, well, in 1976, it was quite prominent in Red Square.
Was built and then destroyed, later, much later. I lived in Moscow. That's why, I know what you're talking about.
Right.
It's okay.
Okay. But yeah, it was fascinating. I'm certainly extremely interested in Russian history, and it was fascinating. Uh, you know,
Let me remind you only that in 1970s, there were no different countries. There were republics. That's why Azerbaijan, Armenia, it was some piece of USSR. That's why, please, Russia created much later as a country. And that's why don't even name it. It's totally different from USSR. Totally different.
yes, in those days it was just different republics, the Union of Soviet Socialist Republics. Yes, so I suppose I'd been in a few of those republics. Um,
Yes, it were republics. It was some outsiders of USSR.
yes, yes.
I'm sorry for this, my question to you.
No, no, I'm
Very,
glad you
I'm
asked.
very sorry for this curiosity because it was much later than I left USSR. That's why it was very interesting for me to see his opinion about what he saw in 2004, 2012 from the West point of view.
Yes, well, no, initially, I mean, I'd be hostile to people, but I would have been, against the ideas, and I would have said, oh, you better keep your mouth shut if you say something critical of the system. But when I was there for the scientific conference, I actually said this at my presentation. I said, it is amazing that I've had to come to the main country of the former, or the main republic of the former USSR, to be able to question these theories, which are not questioned at all in the West. People can lose their jobs for questioning it. So, it was quite free that we were questioning all Einstein's theories and conventional science and so on. But that's why I asked you earlier, do you think one could have done that 40 years before that? Or is it a new development?
Okay, thank you so much, Harry. Let's continue with you because we took too much time. I'm very sorry about my questions about
Well, I
Russia
don't
because
really.
I didn't leave Russia. I don't know what does it mean. Okay.
Well, we can talk a little bit about quasars if you want. We don't have that
Yes.
much time left. The other issue is, oh, I lost the. All right. The other issue is that we're kind of running out of topics here. So I'm wondering if people want to continue on, or if anybody, we don't seem to have as many people here. We only have 6 people. It seems to be a small group.
We do need at some stage, I'm not sure if this is the correct forum, Harry, but to have a brief discussion about this because I'm feeling the same thing about the Saturday sessions. There are not that many coming out. Roger might as well. And I'm sort of running out maybe later on this year uh, with offers of presentations. And so we probably need to talk about what the best format for these sort of talks would be.
Question.
Well, we only have a few contributors, and I'm running out of steam. Unless you want to hear more about fixing Einstein's math.
Yeah, I mean, I don't know. We've thrashed everything to death, but we've sort of repeated a lot of things. And I mean, we have my next speaker is this gentleman Beale back again, Alistair Beale. It sounds as if it's a rehash of what he already spoke about, but he's published a paper in Physics Essays, and he's gone a bit further. So I think it will be interesting. But as I say, I'm running a bit out of steam, and I may have to talk to David in the next, come
Right.
about this.
Okay. Well, so if anybody's got something they want to talk about, might not necessarily be cosmology. You're invited to give a talk. Bob, we haven't heard from you. What do you think about all this?
Well, here's one suggestion. If you like, I could even do it next week, would be to do something on method.
Okay.
Both scientific method and also the method that like on what more fundamentally exists, because it seems to me there are all sorts of these different theories out there, and it's not clear even how to compare them on their merits and things. And maybe to say something on that, it's kind of like people are interested in that.
Well, what
sounds
about
good.
that? What about? Okay, I'm sorry to interrupt. I'm more interested in your thoughts about this guy's dialectical method applied to cosmology.
Well, the only grain of truth there is like opposing forces. And even Hegel had opposing forces like positive and negative electricity or the North Pole and the South Pole of magnets. So there may be a grain of truth there. And I think this guy was matter and antimatter, and you could see those as being opposites. So there's a grain of truth of like opposing forces. But I don't know if you have to buy into much else about Marxism to say that.
Oh,
Yeah.
yeah, I hadn't actually thought about that. That's an interesting observation, Bob. Thank you for that.
Yeah.
I now I get the idea about matter and antimatter. Yeah, I see now how that fits in. I didn't really understand how the matter and antimatter. It seemed like it just kind of like got pulled out of the air. But now that you,
Just opposing forces, but
right. Yeah, that's it. Okay, so from that point of view, you have the opposites, the matter and the antimatter, and then they annihilate, and
right.
then that produces
There's
matter.
your synthesis, I guess.
Right. So you have matter and antimatter, and there's your there, and then that's your opposites, and then they create the synthesis as the matter that emerges from
Ah,
the nuclei of the galaxy. That makes more sense.
Yeah, but it's just the grain of truth. You don't have to buy much else when you say that.
Let me
Well,
ask you the question, guys. When I can see my Gmail, I can see tens and tens talks about some different issues, magnetic atom or something like this. Why the guy prefer to read and to write letters to each other? Why they cannot come to our group and to talk about these ideas with us and to see what is going on? Why they prefer to talk about something in writing instead of discussing?
well, that's a good question. As far as what you're referring to is Roger Monday, uh, he's been sending out these messages. He's been sending out the same picture of gold atoms. I don't know if you've seen that picture of gold atoms, and he's been sending that out for 20 years. And I mean, every opportunity he gets to, he just says the same thing, and every email says the same, sends the same picture associated with every email. So what I do is I just delete them.
But there are a few others. There's a gentleman, Frank, who's very voluminous.
Frank Fernandez.
Yeah, I think that's it. Yeah, a guy, and even Akimbo, whom I've had conversations with, and I'm quite impressed by a lot of his information. He's got very prolix as well. So I think I almost call it trigger happy. It's like they just click on keyboards and they're writing without thinking. And I'd much prefer if we could persuade them to come in and just spend an hour talking to us and be subject to questions.
I think Akimbo gave a talk um, many years ago. I think it was a long time ago.
Oh,
Uh,
did he? Because I had the temerity to ask him to speak within the last couple of months, actually. I said, would you go to the talk? And he came back to me and he said he had a hesitation. Uh, I think he used the word intonation. I'm not sure if I quite understood because his English appears to be perfect in emails. I'd say better than a lot of the other emails.
right.
Yeah, but I think he said he mightn't be understood so well. Uh, Now,
Well,
mind, after Sankar in the last two sessions, I think anything would be,
right.
progress.
Yeah, that was a little rough to take. Okay, we got
Yes.
about a minute or so, looks like. Well, I want to thank everybody for participating today. I'm not sure that I'm going to do anything on Labor Day, which is a holiday here. Um, I don't know if anybody wants to meet on Labor Day, um, over the Labor Day weekend. So that's the end of August, the 1st of September. Um, so I think we'll skip Labor Day.
But that's not next week. It's another number of weeks.
It's 2 weeks. No, 3 weeks, I think.
Very good.
I forget exactly. It's the end of that's the big holiday that we have here, the end of summer holiday. Um,
Well, I think I have a talk scheduled for the 30th of August. I think that's down, yes.
yeah, that's the Labor Day weekend.
Okay. I hope there isn't a problem with that. I have a speaker. I've forgotten who it is, but I could check it up. But he obviously didn't mention this to me.
Okay, all right. Let's see. We got